Hey everyone, Mr. Skelton here, we're back at it. We are doing lesson 9 in unit 6, and today we are going to get to what we've been building towards from lessons 1 through 9, or 1 through 8, excuse me, which is solving exponential equations. The whole point of doing logs, right? What have I been telling you? Logarithms give you what? They give you exponents. That's the whole reason logarithms even exist, is to be able to solve something like this, right? 2 to the x equals 15. In your mathematical career, you have done nothing up to this point which allows you to solve for an exponent or a power. And so that's the whole reason we do logarithms, because what do logarithms give you? They give you exponents. So we've kind of been laying the foundation up to this point, and this is kind of the culmination of the first lessons 1 through 8 that we've kind of done. So got a little situation here for you. It says, is college overrated? I would venture to say no. I know some people would argue, but we're going to go through 2 ways of solving this problem here. So let's go through it. Suppose you and your parents plan on spending $40,000 for college. All right, that's probably a little low. Some colleges are $40,000 a year, but you can become a millionaire much faster just by investing that money. How long would it take to have $1 million in your bank account if you invested that $40,000 into an account making 10% interest compounded annually? All right, so this is going to be method 1 here. We're going to take our, we want to get to $1 million. So that's what we want. We're investing $40,000 at an interest rate of 10%, and it's annually. So we don't need to, annually means 1 time a year, so we don't have to divide up the 10%. Okay? And so now what we want to do is we want to solve for this. So how would we solve for x? Well, we want to try to isolate, what we want to try to do is isolate the exponent. The exponent includes the base and the power. So we want to divide everything by 40,000 first. And you can take your calculator out. And 1,000,000, divided by 40,000 should give you 25. Excuse me. And you have 1.10 to the x. Now, when you want to solve for an exponent, we're going to introduce logs. In math, in algebra, whatever you do to one side of an equation, you do to the other. That's common knowledge. So what I'm going to do is I'm going to log both sides. This is one way to do this. Okay? So I'm going to log both sides here. Okay? And then what I'm going to do is use the power property. Once my logs are introduced, where can this x go? Right? I can expand this. So now I have the log of 25 equals, bring that x out front, x times log of 1.10. And now I can solve for x. I can divide both sides by log of 1.10. My logs cross out here, and I'm left with x equals, and now I got to put that in my calculator. So how do you do that in your calculator? Well, you'll notice that you have a log button right here. And so you'd go log of 25, close the parenthesis, divided by log again of 1.10, close it, and you get 33.77, so we'll just go to 33.8. So what did we just solve? What did we just figure out? X was years, right? So it's going to take 33.8 years for your $40,000 to become millions, or $1 million. And that right there is how we use logarithms to solve exponential equations. I'm going to show you another way to do this problem here in a minute, but before I do that, or in order for me to show you how to do that, we need to talk about this. This is called the change of base formula. And what the change of base formula basically means is if you have a log, okay, and you notice the b and the m here, you can set this up as the log of m over the log of b. It's called the change of base formula. So let's do a quick example. If I said, hey, evaluate this. Now, you know what this is already, right? If what power on 2 equals 32, we know the answer is 5, right? 2 to the x equals 32. If I were to convert this to exponential form, we know x equals 5. But let's use change of base formula to prove that it's 5. So we could write this as log of 32. Whatever m is, 32, the bigger number always goes on top. whatever the base is always goes on the bottom. So we'd take our calculator out, and we would go log of 32 divided by the log of 2, and we should get 5, which we do. So that's called the change of base formula, okay? So I'm going to go back and show you how to do this problem a second way real quick. Let's get it on the camera here. There we go. So I'm going to use change of base formula, and basically we did change a base. You can actually see it right here. We actually kind of work change of base, but I'm going to show you again how this works. Let me go back 1 second here. Yeah, we'll stick with that. Okay. So way number 2, same setup. So 1,000,000. Got to write a little bit smaller here to fit it in. 40,000. Okay. And now we're going to use change of base. So what we do is we start out the same way. We divide everything by the 40,000. Okay. And we get 25 equals 1.10 to the x. Now, to use the change of base formula here, the only thing that's different from what I just did here, and they're very similar, is instead of logging both sides, which I did here in red, I'm going to go log base 1.1 on both sides. And the reason I do 1.0, the reason which is the same thing, the reason I did that is if you take a look at this right here, anytime you have a log where the base is the same as the number above it, what does that always equal? Let's take another example off to the side. What's log base 2 of 2? Well, that's 2 to what power gives you 2? Well, that's always going to be 1, right? Let's go log base 3 of 3. That would be 3 to the x equals 3. X equals 1. What are you noticing here? Log base 4 of 4. What is that? That's 4 to the x equals 4. That's x equals 1. So anytime you have a log base and it's the same number, it's always 1. So the reason you do this method is this x would come out in front. Log base 1.10 of log of 1.10 is 1. So really what you get is just x on this side. And then you can use change of base formula and have log of 25 over log of 1.10. Now you notice it's the same thing here. It's just maybe one less step. Either way works. You're still going to get 33.8 years. Okay? So case in point is whatever this is, whatever this number is, your base on the exponent, you would log both sides of whatever that is to always make this a 1. I'll show you some more examples so that you can get more comfortable with it. Okay, so we're going to solve this one here. If I was doing this problem, the first way you could do it is you could just log both sides. If you just log both sides, then this 2x right here can come out in front. So we'd have 2x times log of 6 equals log of 21, and you would divide both sides by log of 6, and we get 2x equals, we take our calculator out and go log of 21 divided by the log of 6, hit equals, and I get, and we can round here a little bit. Now, actually I take that back. If you can make this exact as possible, that would be better, and then round at the end. So just leave this in your calculator. I'll just put the first few numbers down on paper so you know, but then divide by 2. And so it's in order to solve for x, so just divide that by 2. And now round your final answer to be, we can go to the nearest hundredth, so what, 0.85, right? 0.85. And there's our answer, okay? The second way, the other way you could have done this, is if I go back to the beginning problem here, I'll move this up just a touch. I could have went log base 6 of the original problem, here's the original, equals, and I would log base 6 that side. Remember, whatever you do to one side, you have to do to the other. So this, I just took number 1. In red, I kept the problem the same. That's the problem in red. And then I log base 6 both sides. So what does that become? That becomes a 1, so it's just 2x. And then you would use change of base right here and write that as log of 21 over log of 6. When you do change of base formula, that method, it just takes a step out of this, but it's essentially the same thing, okay? All right, let's take a look at this one here. So when you look at this problem, I think this might be a mistake here. Let's make this a 2. That shouldn't be an x. Let's make that a 2, okay? So let's solve that for x. X is in the exponent there. That's a misprint. Let's make that a 2. So if I'm going to solve this, I'm actually going to do change of base method. So I'm going to log base 2, and I'll do it in different colors, 2 to the x plus 4 equals, and I'm going to log base 2. Again, whatever you do to one side, if I log base 2 to the left side, I got to log base 2 to the right side of the 101. So what does this become? That becomes a 1. That can come out in front, so I'm just left with x plus 4 equals, and then I have to do this in my calculator, so log of 101 divided by the log of 2. And again, I'm going to keep that in my calculator because what am I going to do to solve for x? I'm going to minus 4 from that answer. So minus 4, then I get x equaling 2.66 if I round to the nearest 100. Okay? Flip it over. So now I have 2 more. I would like you to try number 3 on your own. I know it says 3 ways, but for the sake of time, we're just going to keep it one way, or one of the 2 ways that I've showed you, and then we'll check back with you. And actually try number 4. Number 4 is a basic one, just change a base, but I'd like you to try it anyways. Okay, let's do number 4, since that's just a basic change of base. So, right, if I saw something like this, if you think about it, if we were to go what we did in the very beginning, we'd say what power on 3 equals 15. Well, if you think about that for a second, you know you can't do this mentally, right? 3 squared is 9, 3 to the third is 27, so it's somewhere in between 2 and 3, but we can't do that because it's not nice and neat, so you have to do change of base. Log of 15 over log of 3. Take your calculator out here. So log of 15, close parenthesis, divided by log of 3, close, equals 2.46, right? 2.46. So we said it would be between 2 and 3. There we go. This one here, what are you going to do to both sides? Well, you can do whatever method you choose. You can log both sides, or you can log base 2 both sides, because you want to access this, right? So I'm going to go log base 2 on both sides. I'll use different colors here for you. Whatever you do to one side, you got to do to the other. So log base 2 of 172. And so what happens with this? This becomes a 1. I can use the power property and bring the 3x out in front. So I have 3x times 1, which is 3x. And then in my calculator, I'm going to go change a base. I'll write out the step, 172 over log of 2. That's change a base. So log of 172 divided by the log of 2. And that equals 7 point blah, blah, blah. So basically I have 3x equals that decimal in my calculator. And then I'm going to divide that by 3 to get my final answer, which is 2.48, rounding up to the nearest 100. Okay? Now, the very last question is a tough one. A lot of people get this wrong on a quiz or a test because we always sneak one on there. So I want to make sure you pay attention to this one. Quiz test. Yes. Okay. Change this logarithm from a base of 2 to a base of 6. Okay? So, a little different here in how we would do this. Basically, the first thing I would do is rewrite this problem to give me a variable. So I'm going to do something like that. Now, what we want to do is basically all we're doing when you read the directions, change this logarithm from base 2 to base 6. Basically, what I want to do is figure out what x is. Okay? And so what I'm going to do with this right here is create a decimal. And the way I'm going to do that is I'm going to use the change of base formula. So I'm going to go log of 10 over log of 2. So log of 10 divided by the log of 2, hit equals. Now I'm going to leave that in my calculator. So right now I basically have, well, I guess I'll round this one here. I'll just go to 3 decimal places. So I have 3.321 equals log base 6 of x. Okay? Now again, we're trying to solve for x here, but look at what we have. Once I have this, I'm going to convert this to exponential form. Watch what happens. What power on 6 is x? Well, we have the power, right? Logs give you exponents, so this would be 6 to the 3.321. Now I left that on my calculator. Okay, I rounded it because I wanted, or went to 3 decimal places because I wanted to leave it on paper for you, but I'll show you what we can do. 6 to this equals x. So what I can do now is leave that decimal in my calculator and go 6, get this on the calculator, okay, let me just I can go 6 caret button, which means raised to my second answer that was just stored, and hit equals. So now x equals 384 point, I'll go 56. So now I have answered my question, because the original question was, what is this question mark? What is this? Well, we just figured it out. X is this, so now my final answer is log base 6 of 384.56. So I converted log base 2 of 10 into a log base of 6 of 384.56. Okay? So use change of base, create the decimal, convert it to exponent form, solve for x, plug your x back in, and that would be the answer. Okay? And you'll see one of those homework quiz and tests for sure. I know this can be a little challenging. I'll be happy to go through these with you as we move forward, but this is the whole purpose of all the logarithm stuff that we've been working towards, is so that we can solve equations and we can solve for exponents, because up to this point we have not been able to do that. All right, look forward to seeing you in class, and like always, ask away so that I can tie up any loose ends for you. Take care.